And finally, all this technological and methodological context paves the way to new approaches to track the path from raw data to interpretation and knowledge production. There is not so much time left before I give way to Roxane for the presentation of IOLI in action, so I will be brief. Here, the convergence of quantitative and qualitative descriptors in a same 3D reference system allows us to consider really new ways to analyze the link between some observations and some geometrical visual characteristics, but also to study the privileged path leading to the observation of a specific phenomena. With this idea that maybe we can find and characterize some maybe some recurrent patterns in the way some experts look at their study object. And of course, during this presentation, I focused on digital tools, but we must not forget on-site practices because they remain essential, and also because their simultaneous comparison could tell us many things about the way the tools influences the way we look at our object of study, about the biases and openings that it can bring. The example you see here is the real and virtual anastylosis of the collapsed transverse arc of the nave, which is the topic of Anais' presentation. So we won't talk about it later. Okay, so I stop here. I'm sure Livio would have so much interesting things to say about the Digital Data Working Group activities and its ambitions regarding 3D and web technologies. But anyway, I hope that I've been clear enough. And in any case, feel free to ask questions at the end of the session, and we will do our best to provide the needed clarification. Thank you. So now maybe we can keep the questions for the end, and because the next presentations will be probably more eloquent and bring a new light on some topic I just quickly mentioned. So now I give way to Roxane for the presentation of IOLI for the architectural diagnosis.
Thank you, Violet, for this first presentation. Can everybody hear me for the moment? Yes, perfect. So I'm immediately going to share my screen. And can you see everything? Okay. So as previously mentioned, I'm going to talk a little bit about my work in an approach to build a complete digital report for the cathedral within the IOLI annotation platform. So how is this presentation structured? First, I will speak a little bit about the first experiments that were made in order to build the final version for the digital report. And then following with the process to classify and create the different projects on IOLI. And finally, the work regarding the annotation and every semantic enrichment that was made on the different projects of IOLI. So a little bit of context as an introduction. So what was the timeline for this work? The first experiments were made at the end of the year 2019 and lasted until the month of March 2020. And then the creation for the digital report for the outside of the cathedral was the first one to be done. So the creation of the project was during the summer of 2020, and the creation of the annotations on those projects a little bit later in that same year. And the creation of the digital report for the inside of the cathedral is much more recent, since it began in the spring of this year and ended only in August. So you will see maybe in the presentation that these, you can see differences between how the outside and the inside was sometimes treated, but this is explained by the timeline of the work. So a bit of the first experiments that were made, what were the goals, what were the things that needed to be tested. So first, what was important to do was to try to build the projects with the collected data. So every photogrammetric acquisition that we had at the time. So as a reminder, this was in the end of the year 2019. So we started to collect informations and images. So the goal was already to try to create projects and see if we had a point cloud that could be annotated, if the projects on IOD were dense enough to be annotated. And the second step, of course, was to build a series of annotations on these projects. So could the platform handle multiple hundreds of annotations in a single project, for example? Could we still navigate quite freely if the annotation were rightly projected onto the point clouds? So we had annotations that could be really small or at the opposite, very, very large. So we had to test all these different possibilities for the future projects. And also the goal was to already try to test the classification and semantic enrichment. So with these first personal observations, add many information concerning the state, the time the annotations were made. So here it was really made as an experiment to add all of these user descriptors and joint files to try to add as many information as possible regarding the annotations that were made here as experiments. And finally, these questions had to be applied on multiple objects. So you had previously seen a bit of these projects were for the vaults of the cathedral, but you also had the remaining woods on the outside of the vaults, or here elements of the outside and the walls. So the second step of this work was the classification and creation of the final projects, since the first experiments were quite positive that we could build a digital condition report on the IOLI platform. So the first step was to manage the large quantity of images that we had. So Violette mentioned already a bit of quantities of data that we had collected, but for only the images regarding the photogrammetric acquisitions, I had around 100 images using different technologies such as camera, drone, or even cable cam. And in the final results, for the moment, we used approximately 1,500 of them. So how to organize and divide these images into smaller projects for IOLI. Here was an example of the work that was made to divide the images for the outside of the cathedral. So we had a segmentation that was both horizontal and vertical, in the sense that you can see, for example, for the choir and the nave, we had a division that was made on 3 different levels, but also a division vertically that followed the spans. So this was a division that was meant to follow the one made by the architects in the initial condition report, to try to mimic and be as close as the original work was made. And here is the division made for the interior of the cathedral. So we had projects that were a bit larger. For example, we were not necessarily working span by span, but we had, for example, a point cloud for the entire vaults of the nave, one for the vaults of the choir, etc. And on the other hand, we had lots of point clouds for the chapel of the cathedral. Each individual chapels of the nave and the choir had its own point cloud. So we were really working on different scales for these type of projects. And so a quick word on how the projects and the point clouds were created on IOLI. We had 2 different possibilities. The first one is to create a project directly in the IOLI platform, where you just have to upload your images and the point cloud is then calculated using micmac, or you can also create your own point cloud on Metashape Pro, for example, and then import it into the Aioli platform. So at the end of the first step of creation of the projects, we had 205 Aioli projects, 46 that were not meant to be annotated, that were more of scenes that were ready if we had a need for them in the future. And we had 159 projects that were meant to be annotated, with a total of 116 for the outside of the cathedral and 43 for the interior. Finally, this work of annotation that would soon follow was made in a collaborative framework, in the sense that one account, so the NDP for Notre-Dame de Paris, was the owner of all the projects, was the owner, the one who created all these projects in the platform, but then could shared every one of these projects with different users that represented the different groups that created the reports that were then annotated in the platform. So for example, MOE, which standard for the architects, was the user that would annotate every observation made by the architects considering the digital report. And we also had accounts like LRMH and LERM, Parent Restoration and GTNUM, who were more of the scientific analysis. So for example, we had a radar analysis, we had a stratigraphic analysis. So all of these were also integrated with these accounts on the project. So also here is a bit of an illustration on the source. So the sources used are directly the reports that were made by the user I mentioned just earlier. And this is a bit of context on how the semantic enrichment can be made on the platform before I move on to the whole process of the annotation. So as I mentioned a bit earlier in the testing process, you had the possibility to create user descriptors, and with these user descriptors, you could add a lot of information regarding what was previously observed by the different professionals in the field. So for example, here you had different fields that were made to add a bit of text and context, which was already present in the condition report. And you also always had a mention for the source of the annotation, so to mention what report was originated for each one of the annotation. As well, you also had the possibility to join files. So these could take many forms. It could be complete reports, so complete scientific analysis, but also selected and extract pages. So it could be also different formats such as PNG, images, or directly PDF. And here is for a bit of illustration of the work, now that we have a bit of context, I hope. So here is, for example, the creation of a project using directly the Aioli platform. So as you can see, I added my images and also coordinates that allowed me to place every project in a common 3D environment that you will see a bit later. So here I had the possibility to share the project with an architect user. And you can see here the process to create groups and layers. So it was a bit fast, but as you can see on the left, you have the possibility to organize the different annotations into two different groups. So you have the group that contains layers, and the layers can then contain annotations. So here is also the description sheet. So as you can see, you can name every one of your field and then add these as your descriptors that you can then fill in in each one of your annotation. And here is what it looks like when you are on the 3D point cloud. So here you can see all the annotations that were made in the group of the diagnosis. And here is what it looks like in the 3D viewer. I will show that a little bit later. So here's another example, this time for the inside of the cathedral, since we previously had a scene for a span of the outside. So here is a project for the vaults of the nave. You can see a first layer concerning the radar analysis with its joint files that we just saw. Here is, for example, something a bit different, which is a bit of context on the previous observations that were made on the nave. So you have, for example, a precise description of the previous work that were made on the nave. So before the fire, and the different, here you have the different dates of every element that were already known. And here is a quite important layer, since it contains a lot of annotation, which is the one for the diagnosis of the different stones. Here you also have the diagnosis for more precise elements of the vaults. Here you can see, for example, that we really try to follow the colors that were made in the initial diagnosis that you could see at joint files. So we had this really blue and red colors that were directly reported in IOLI. Here is the same principle for the deformations of the vaults. And in 3D, you also have, of course, the possibility to see each of these annotations. So you can quite freely choose to show layer by layer the annotations, or you can also show an entire group if this is relevant to your study. And here is what it looks like in the Notre-Dame viewer. I will explain a bit later, a bit of context between the differences between the two. So here you have all the same layers that we previously seen. So a bit of details. So here we have what I previously shown in the video regarding the interior of the vaults. So this is a quick reminder of this. We have 3 annotated projects. So for the nave, the choir, the transept, but also divided in 5 groups and 9 layers, and using 5 different users. There was also a work regarding the vocabulary and how the elements were named, and how we could normalize the different name for the annotations, what is presented in here, where you can see the color code and also the way that each alterations, for example, would be named inside of the project. Here is an example of what the exterior of the vaults annotations look like. So we had this time only 2 layers, but also very rich regarding, for example, the diagnoses that were made on the stones of the vaults. The walls as well, which this time included also multiple actors. And we also had a radar analysis, so adding a scientific aspect as well. And finally, the chapels, which are presented here in the little video. So we had 2 main groups for the chapels, the diagnosis one once more, but also a lot of general information. So for example, we had lots of information regarding the paintings presented on the walls, or also the different elements constituting the ground. And finally, once we have these projects in Aioli, you have a multiple way to consult them on different platforms. So here, for example, is a platform called Spritz2. My video paused. Okay, it's not working. Too bad. Oh, no, it doesn't want to work. So here I will manually animate the video. So this viewer allows to consult the scene a bit more freely than Aioli. One important aspect is that you can share this scene with someone who would want to observe it, but if you don't want this person to make any changes to the projects, not modify or add anything, this viewer allows you to do so because they will have the possibility to see every annotation, every description sheet that was made, but not allowed to modify the selected projects. And you also have a bit more freedom to show or hide the desired groups and layers. And very quickly, when I mentioned the 3D viewer, Violette will explain more in detail at the end of this session, but it was also a very important tool to create this diagnosis since in Aioli, as you maybe understood, we were working on different smaller projects, smaller scenes, and the Aioli viewer, thanks to the 3D coordinated added to the projects, allowed us to see the projects in same environment. So instead of seeing project by projects, we had the possibility to consult 1, 10, 20 projects at a time, and so to work maybe at a different scale. So what, how many and how much data do we have following this work? So at the time, on the 159 projects annotated, we have a total of 565 layers and more than 7,000 annotations. So this work is still expanding to this day, since we are still creating projects, for example, for the main facade. So we will also have another 100 annotations coming this month. So this work isn't really ever finished, because you can always add more information. You can also add new analyses that were made. You can add new observations. So this is really a work in progress, I would say. But for the time, yeah, we have more than 7,000 annotation to that collected all the different data by the 6 different users that I previously presented. So thank you for listening. If you have any questions regarding this diagnosis, I will try to answer it at the end. I tried to be very brief, so I hope everything was clear for you, but thank you very much for allowing us to present this work.
Thank you, Roxanne. Maybe we will directly leave the floor to Marco.
Hello, everyone. Can you hear me and see me?
Perfectly.
Okay. Good afternoon, everyone. I will present our work on a very small subset of visualization of this extremely large project. And first of all, I'm Marco Caglieri. I'm a senior researcher at in a small computing lab, in a small computer graphics lab, which is the Visual Computing Lab, and it is part of the Institute of Science and Technologies of Information, which is part of the Italian National Research Council. So we are a group of more or less 20 people that work on different aspects of computer graphics. We have a long collaboration with Livio and Luca, and we were involved in this project for a very specific task. So visualize and make possible to interact in a very up close and personal way to one of the different parts of the restoration. So taking care about the fallen vault rib, that is one that collapsed in the middle of the the arch, and it's made of stones that have been recovered from the nave. So the idea was being able to visualize and interact with this stone, with the possibility of doing some technical work in terms of inspection, measurement, and annotation. So first of all, we needed all the data, and so worked in collaboration with the people doing the scanning. So the stones were digitized using a custom photogrammetric rig made by Luca, that is a colleague and friend of long date. And it was able to build pretty good model of this stone that doesn't look that large, but in the end they are still a sensible chunk of stone, and the result was a set of nice 3D model, very detailed and able to capture all the detail and all the geometric features that were of interest for the people working on the study and the restoration. During the processing was used MeshLab, which is our tool for visualize and process 3D data coming from digitization. And the result is a set of almost 70 3D models of these stones. It's important in this kind of project to have all the data as uniform as possible. So a lot of care was used to generate models that are more or less homogeneous in terms of resolution, in terms of detail, in terms of fidelity of color, and that could be compared and used simultaneously. That was really important, because it's not visualizing a single object. When you need to visualize and make accessible for work a set of objects, that is an important part. So we actually spent some time in deciding all these parameters and taking care that all the models were the same, were comparable, and also were positioned in a coherent way. Positioning and choosing the reference space, it's another very important part of this kind of work, and it's something that you have to take care before starting to gather all the data, and how it is visualized and how you access to the data is strongly dependent on this kind of decision. So even though the acquisition part does not seem so relevant in terms of designing a system to interact with the object, it is, because all of these decisions bear a lot of influence on how you will work with this data. And then, so after we had all the data, we had to display it online. So how to do it? So we used our another tool that we developed, which is called 3DOP. It is a framework for creating visualization of 3D object on the web. The tool has been designed to be used for cultural heritage, and it's an open source tool. It uses the same basic ingredients that most of these tools use. So it's using JavaScript, HTML5, and WebGL. So it works across all browser and platform. One of these main feature is the ability to work with high resolution geometry, thanks to a multi-resolution engine that makes it possible to effectively stream even a large 3D model and efficiently render them in an interactive way. So it was possible to display the stone and in the resolution at which they were scanned, and it's also possible to display more than one element at a time. That we have not actually used this feature, but it will be probably done in the future. Another key aspect of 3DOP is the possibility to really customize it depending on the need of a specific project. So you start from a very basic set of tools and you're able to build a custom interface and custom functionality that makes possible to create an interactive tool specific for a project, from things that are completely focused to dissemination to the public, to things that are more a technical interface that enable the creation of data by the user, annotation, and technical work of inspection and measurement. And that was also a key aspect of the project. So finding a way not just to visualize in a bare way the object itself, but designing how to make possible the interaction and try to make this interaction usable by people that may not have been expert on manipulating 3D data in general, not just on the web, but manipulating 3D data. So the system itself is basically a gallery of these elements. So it starts with a basic page that show all the different stones, and then you have the viewer that lets you interact and measure and annotate the different object. I'll go through some of the detail, and I'll show you how it works. So first of all, we spent some time in deciding how to navigate the object, which is one of the hardest tasks when you work on 3D object, because every interface is slightly different, and you need to find a way to make possible for the user to interact with the object in the most natural way. So since the beginning, we decided that it was needed to be able to get the object from, see the object from every possible angle. And you already have a choice. How do I show the object in every possible orientation? So you can use a 3-axis trackball, but it's generally a bit harder to use, especially for people that are not expert in 3D. So another way is to use a turntable, so something that lets you spin the object along 2 axes, and you can pan it and you can zoom it. And this makes much easier to interact with the object, especially through a web interface. But it makes not so easy to reach every possible angle. So to enrich this basic navigation, we make it possible to have the object in the 2 positions that are the one that are used by the restorer at the moment. So one pose of the object, so with the object lying down, is how the object is normally stored at the moment in the while they work on the stone, and the upright position that is more akin to the original placement of the stone. And we make possible to switch between these 2 poses and make sure that everything works seamlessly across all the different functionality. So the navigation, this is the basic page with all the objects that are in the system, and this is the basic navigation page. And you see that the navigation happens on these 2 axes, so the horizontal and vertical axis, plus zoom and plus panning. And it's possible to keep the object upright or flat and navigate it as it please. In this way, the navigation follows exactly the same procedure that are used on the physical object, and provide the possibility of looking at the object from all the possible positions. Moreover, the navigation also use the standardized encoding of the phases, so each phase is numbered, and the same numbering is used on all the different objects. So these numbers here, so this icon here, help in providing some fixed point in the navigation. The user can also refer to this gizmo here that at any time show the actual pose and the relative position of the different phases. So we try to make the navigation in the exploration of the piece as standardized as possible and as coherent as possible across all the different objects. So if you go on side 1, it's always the front piece front part of the object, the one that was facing the inside of the cathedral. So this is what I was saying about having a coherent orientation, having a coherent data set to make easier to not just navigate, but to effectively work across different objects, because you can relate the different faces depending on their semantics, not just the pure geometrical information. Another important aspect was the tool used to interact with the object and to measurement. So it's possible to use the real-time cut-through sectioning. The 3D-op already offered the point-to-point measurement, and we also added the angle measurement to measure the angle between the different parts and the angle between the different scratching and marks over the surface. We have metric grids that help you in understanding a bit better the size of the object and to provide a way to effectively measure and have a reference on the different metric measurement, metric reference on the different parts of the object. We have a screenshot, and it's possible to combine all these tools to really understand and explore the object in detail. And it's possible to change the rendering style and parameters to highlight and get a better perception of the detail of the surface and of the geometric feature and shape of the different object. Another important aspect that we wanted to include was the possibility to not just look at the object and measure the object, but being able to generate some information while working on the different objects. So it's possible at any time to add a note on the whole object, but also do a thing that is you can save a view. A view is not just the view position of the object, but also of all the other parameters that are in the view at that moment. So if I spot something looking at the object from this angle and with this specific rendering parameter, I can save a view and add some text that describe what I want to save, what I want to associate to this view. And I can then continue working and change my rendering style and whatever. And then maybe save another view. At any time, I can go back using these as bookmark, as annotated bookmark that bring me to a sensible point on the object itself. And then we have the possibility to add spot annotation. So I find something relevant here. I add this point, I configure some rendering parameters, and I can save and annotate it for later use. So these annotation tool are a bit basic at the moment. We plan to add more annotation methods later on, but they are already something that can be used to not just browse the object and look at the object, but also create new information that are located on some part of the object. And this annotation can be exported, can be stored, and can be shared with other people working on the same object. So to make possible an interaction between also the people that work on this task. All these annotations are georeferenced on the 3D model, and since all 3D model have the same reference space, have a coherent reference space and a real-world measurement, it's possible to also use this point of view and annotated areas for inter-exchange, and they're compatible with all the rest of the project in the same reference space. So we are happy of what we have done, and we think that the viewer that has been designed and then refined using the input of the user. So what you've seen is the final result of this evolution. It's already something that can be used in a technical way to work on the 3D model and create new information and new knowledge about this stone, working on a purely virtual way. But we know that there's still a lot to do. So the thing that we want to work, as I said, is the make possible to add more complex annotation. Already have a couple of prototype, but still not online for the project, and it's possible to add the points, polylines, and areas also beside that point annotation. And I'd love to add a more complete dimensioning interface, so something that you can use not just to measure one specific feature, but to enrich the model with a lot of metric information that help understanding the size and the geometrical characteristics of the object. And I also need that we need to work on a more advanced shading to enhance the readability of the chisel mark, which are pretty visible also in this prototype, but they could get more attention with a bit more advanced shading. And then possibly a multi-element viewer, so showing more of than one piece at a time, maybe in the correct relative position. That would be an interesting visualization to combine the high-resolution 3D model plus the actual positioning of the different elements. So thanks for your attention, and if you have any question, I'm available.
Thank you, Marco. Well, I don't know if we answer a question now or if we could keep it for the end of the session. So
yeah, let's keep all the questions for the end.
Okay. So Anais, if you want to share your screen. Thank you, Marco.
Do you see my screen?
Yes.
I don't see it. I'm not used to use Teams usually. I'm really sorry.
What's the problem?
I don't see the presentation. Oh, okay, I see it now. Great. Sorry for this. Thank you for this session. My name is Anais Guillem. I am architect and archaeologist, and I am specialized in digital documentation and ontological modeling. But today I'm going to present the collaborative work on the digital and physical anastylosis of the collapsed arch in the nave of Notre-Dame. So I will show the intricacies between the physical and the digital, as well as the numerous and fruitful collaborations between the different actors and institutions in order to reconstruct this arch. It's a bit like a detective story with
yeah. Because we only see a black screen. We see the top. We see the top, but
do you see the
presentation now?
We can see it, not in the diaporama mode, but in the editing mode. And when you press the diaporama, we saw
okay,
it. Yeah, it's better to keep it like that. Yeah.
Okay, but then I will leave it that way. So it's a bit like a detective story with clues to solve the mystery of the reconstruction for my part. So the case study is the collapsed arch F2930 that is located in the nave. So it's located one span west of the choir, and it collapsed due to the fire in April 2019. So the objective of the repérage project is to track the voussoir and elaborate a reconstruction hypothesis of this arc. That it's like we know the objective, but we don't really know how to do that. So we had to discover, like along the way, our method and methodology to do so. So here you can see different data sets in Aioli that represents different juxtaposition of data. There is the initial point cloud of Andrew Talon that was made in 2010 before the fire. So it's a great data set because it's the main data set that we have of the cathedral before the fire. So it's an architectural survey. That means we have a good idea and a good accuracy for the architectural elements, like the vault, but it is lacking some details, like for the reconstruction about the voussoir, the mortars, etc. And with those, the great thing with Aioli is that we can have different data sets, including like other point clouds, other scenes made during the cleaning operation, the reconstruction, the consolidation works, and etc. So we have like a great, rich environment to cross-analyze different data sets. The physical anastylosis was initiated by the conservation architect Pascal Prunet. Anastylosis means that it's the activity of reconstruction for a damaged structure or building. And I will use both of the terms, reconstruction and anastylosis. So to give you an idea, there are like 79 fallen voussoirs elements. So those are the stones on the ground that you can see. And 76 were identified in the remains. So we are missing 3 voussoirs that were lost due to the collapse. So it's pretty good. The collection of the voussoirs, we want to understand what was their initial location in the arc. And for that, the stone working group, the LRMH, this is the historical monuments laboratory, and the conservator architect team that made the choice to start with the physical anastylosis on the Notre-Dame site. So the great thing was it created a working sessions where we were able to discuss and to start thinking about the problem of the reconstruction. So there are many actors with very different backgrounds. We have archaeologists, we have architects, we have like engineers, we have art historians, building archaeologists, and etc. Conservators and geologists, and so on and so forth. But the difficult part was to bring people together to talk and to discuss the different hypotheses and methods. So here is it's interesting to see how the digital and the physical enrich each other. So we start from the Talon point cloud that gave us the starting point to extract information and draw a section that you can see on the right, a section of the arc that was then printed on a tarpaulin scale 1 that you could see on the previous slide. You can see on the ground there are some drawings. Those are the drawings of the section. And from this printed tarpaulin, we tried different combinations, especially because of the dimensions and because of some specific elements on the stones. So this step was very important to see that first, the initial reconstruction hypothesis was not great. We only could locate 4 stones with certainty and some with more like uncertainty. But what was very good was to define the archaeological predicates for the reconstruction that were the reconstruction criteria. So this was really the starting point of the reconstruction, working together, and this result was visualized and imported into a virtual anastylosis that was initially a parametric model that gave us like an idea about the different volumes and shapes, but none of the provenance of the different like stones. So again, this back and forth between the physical and the digital, we can see that the parametric model is enriched with some of the models that were presented by Marco. And you can see that the different voussoirs start to appear at their location. But what is also interesting is that the photo on the right, in the corner, shows the lapidary mark of one stone in situ that is like preserved. So it's the last stone that remains in the cathedral. And we can see that the lapidary mark is towards the ceiling. And that means that we applied this criteria then for the reconstruction hypothesis. So it's always a back and forth between observation on site, observation on the voussoir, and the digital environment and the processing. So what's the anatomy of a voussoir? A voussoir is a type of stone that is an element from an arc. So it's more or less a stone with 6 sides with some decoration. So the numbers of the sides were established by the archaeologists to have a sort of system where the side 1 and 2 are the intrado and extrado. That means intrado is the side that is inside, that is visible from inside the cathedral, from the nave. The extrado is like not visible, it's covered by like the vault. And then you have the side 3 and 4 that are also visible, and the side 5 and 6 that are the seal surfaces, and one of them has a mark. So you can see that there are different features, like notches that we can see on the picture on the left. And the lapidary mark is usually on one side. So we don't really know exactly the meaning of that, but it's a sort of system to help the construction and the work in the building process. So there are also marks of polychromy and molding features that helps us to recognize the voussoir in the remains. So in this slide, it's more about how do archaeologists study the voussoir. It's more about the lapidary study that gives more structured data and more systematic data about the observations, and it was the data sets that allows us to go on with the reconstruction later on. So aside working with the archaeologists on the 3D models on site, there was also an important work to do with them to digitize their data sets and to make sure that they document it properly. So, and to structure their data. The typical archaeological documentation is also very like the one on the right. It's a sort of ortho photo or drawing that gives a very synthetic view of the stone, and it's very complementary with like a perspective view or documentation in 3D, because in one document you can see immediately all the different sides of the elements. So it was an interesting experience and experiment to work with the archaeologists to see if they were able to do the same work they were doing on site with their forms and to do their lapidary study, but to do it like online with 3D op, with the 3D models. And we can see on the upper part is the old version of the viewer, and on the lower part the newer version of the viewer. So there were really improvements that really helped the appropriation of the tool, and it worked pretty well for them at the end. So the conclusion in this user test experience was that we can do more or less the same observations and analysis, annotations, but depending on the context, both the on-site work and at-home work is very complementary. So why is it complementary? Well, in the physical on-site, we have this wonderful direct observation with like very traditional workflow for the archaeologists and other specialists. So it's very comfortable for that, but in the same time, due to Notre-Dame organization, we have real accessibility obstacles, like because of work authorization, safety protocols, and so on and so forth, but also handling problems like stones are very heavy. They are stored on pallets. So that means if you want to reach a pallet that is stored high on a shelf, it's very complicated to get it. So the accessibility obstacle doesn't exist in the digital. The digital show grades has a very good accuracy to look at tool marks, even like also the lapidary mark in the shape of cross and so on and so forth. So we had really much to adjust the digital protocols as close as possible with the digital, with the archaeological research. So how did that happen? First, a questionnaire to start to see if the user was the user was happy, if he could like appropriate the tool, and what was working and what was not working. So the archaeologist Cédric Moulis was really excited about the tool, and we did like even more than that. We also had an interview and work sessions together, and it was very interesting to see how there was a continuity between on-site work and digital work. So, but even if we can observe the voussoir on the 3D models, it doesn't give us very much information. It gives us an observation about the voussoir after the voussoir collapsed, after the cleaning operations by the machines due to safety protocols. And also after sorting and temporarily store artifacts on pallets. And they were also inventoried like briefly to have an idea about the artifacts. And so all of that was done by the archaeologist, the state archaeologist, and the LRMH. All these steps were documented by photographies, like systematically, and it represents like 13,000 pictures of the cleaning operations. Those pictures were indexed and the metadata were extracted. So all this protocol of documentation was done for the emergency operations, both in the field and in the lab. So it's interesting to see how there is a continuity of documentation between the different tools in the digital working group of Notre-Dame, because the tags and the metadata and more generally the concepts used for the documentation of the pictures were documented in OpenTeso in Thesaurus, a Thesaurus tool, and to identify the context of these images. And these images were archived in ArchaeoGrid, an archival information system. So the trajectory of the voussoirs is not finished after that, because once they are extracted from the nave, they need to be cleaned, decontaminated, and then we can start the further analysis or digitization. You can see the difference of when Eloi digitized the stones, they are very clean, but before they were like very dirty, full of lead. So in between there were interventions of conservators to decontaminate them. So we saw that the voussoir fell into the nave, and thanks to Aioli tool, we could add different data sets from the cleaning and sorting operations. And thanks to that, we could identify some voussoir elements, like in the second picture. The X001 is a voussoir element that is identified and in a picture, and then this annotation can be projected in different other pictures in 3D, and then we can look in a data set before and after in time to see where these specific elements appear in the nave. And so we can deduce the fall location of this specific element and when it appears in the dataset. So from there, we identified a stone that has a type voussoir in the remains, and we know when it appears and where. But what we don't know is which voussoir it is, because we need to identify from the conservators' datasets and pictures, or from the 3D models, or whatever documentation, which voussoir and what is its inventory number. So in this case, it's the N28. So that we need to compare different datasets to identify its number. So how it looks like in reality. So on the left, we have a photo of the remains. So there are everything down, like voussoir, but also a lot of different remains and artifacts. And in IOD on the right, you can see a picture and its projection in the scene. So at the end, we have annotated different like voussoir, and so we know their locations and their fall positions. So in this case, we have the N1, A, B, C, and D that were located more or less in the same area. And we know that it's a cluster, and they are located in the same area in the reconstruction. And they come from the same cutting bench when they were produced and extracted. So before that, we had this problem of reconstruction, and we had archaeological predicates. And there are too many possibilities, because when we did this physical anastylosis, we could not really much have a proper hypothesis, like with a good certainty. So the next idea was to go towards the modeling of an optimization problem. So I'm not a mathematician, but we had the help of Benoît Duvaucel, that is a mathematician, and Antoine Gros, that is an engineer. And working together, we could define the function and the constraints as they were like defining the predicates. And so that's what is illustrated in this slide, that are the different pairs, the location of the mark. Is it like towards the ceiling or towards the ground? The width of the elements, the fall location, and the presence of or absence of notches. Those are the different criteria. And thanks to those different criteria, we could have a model with like of optimization, And thanks to all those criteria, we could go up to 73% of certainty on the model. That is much better from the initial reconstruction. So this is a visualization of how it looks like in the viewer, like with the models, like realistic models, and their reconstruction location, as it is like in the last hypothesis. So what is interesting is like this work between the physical and the digital goes also into the dissemination, because the printing of 3D models into sorry, the 3D printing of the voussoir allowed us to have like pedagogical material for the general audience, but also to communicate between the different researchers and actors in Notre-Dame. So I want to thank like all the team and all the members, both of the project and the different working groups, because thanks to them, it's not the work of one or two people. It's really a work of like a very large team working on different elements for a very long time. So thank you.
Thank you, Anais, for this great presentation and very clear presentation. Maybe I'll move on as we are a bit late, and then I'll try to be as quick as possible, and then we take a bit time for some questions. You can stop the sharing of your screen. Thank you. Okay, does it work? Do you see my? Okay, great. So here we are for this last presentation. I leave Livio's shoes as I prefer mine, and I will talk about the 3D viewer developed to centralize all the resources collected around Notre-Dame in the same visualization system. So have you seen before the digital data working group has many activities, but they mainly try to converge towards a common goal, which is to propose this digital ecosystem allowing to document in space and time all the restoration sites, so that we keep a kind of digital memory, not only of the monument, but also of all the related research and restoration activities. So obviously it raises many challenges, be it regarding data collection, which requires tailor-made methods to produce or aggregate highly heterogeneous data within a single environment, but also regarding documentation and semantic annotation to enrich this big corpus with multi-thematic expert observation, as Roxane has really clearly pointed out. And of course, regarding the exploitation of the data, either through specific use cases, as shown by Anais and Marco, or through the construction of new analysis and visualization mechanisms. And I think a really good example showing the importance of all these challenges is the work done by Kevin Jacot, a colleague. He focused on the geometric restitution of the rough structure before the fire. In fact, even if laser scanning were done a few times before the fire, the 3D data concerning the rough structure is still absolutely not exhaustive, mainly because of its complexity. We called it the forest. So given this heterogeneous and fragmentary and even sometimes discordant documentary resources, Kevin had to rely on architects' drawings, but also on several thousands of pictures from various sources, and of course also on laser point clouds, okay, incomplete but still rich in information. And from the analysis of all this data, he was able to propose a manual modeling of the wall structure before the fire at the scale of the architectural detail. Well, I think that this meticulous work clearly illustrates the need to simplify the data mining operations and also the analysis of possible overlappings or divergences and their overall manipulation and visualization. So it's definitely the idea that motivated the implementation of some services, some methods or tools to document and enrich collected data on the basis of a shared control vocabulary to pave the way towards the exploitation. Like, okay, at this point we are able to collect big amounts of data, several hundreds 3D models of point clouds, thousands of images, but now how can we ease their exploitation? I won't spend so much time on the dedicated services, but basically to do that, the main idea is that we must allow people to easily find resources that match their interests. It's the basis. So we obviously have to document this data, that's to say to describe not only the files themselves, their nature, their origin, precision, and so on, but also the information they contain, the concepts they support. And of course, it's fundamental that this description work be based on stable vocabulary elements that reach a kind of consensus among all the communities involved in the project that often speak different languages. So a first tool has precisely this aim to allow the structuring of multidisciplinary theory by defining both concepts and the relationships that link them together. And this theory can be used to drive indexation and ease the search for information. And then, now that we are able to collect data and that we have a vocabulary to support descriptions, we can focus on their enrichment. So, as I said before, to do so, the NDAM platform includes two tools. The first one is called ArcheoGrid. It allows to index the data by relying on these thesaurus terms and on description models such as Dublin Core, or also on more specific models defined by each working group. Here again, I pass quickly, but for those who are interested, there are videos to deepen this topic on our website. I show the link at the end of the presentation. And the second tool is IOLI. As we said, it is dedicated to collaborative semantic annotation for the documentation of heritage objects. Again, I won't elaborate further as Roxanne has shown it in action in a really clear presentation. But my point is that if we use all these tools together, we'll reach a point where we are able to collect all the digital data produced all along the restoration sites, to describe them, to enrich them. That's to say, to create a significant corpus of resources, all related to the same cultural heritage objects. And as you can see, these resources are really heterogeneous. They concern various temporal states of the monument, various areas of interest. They are also of very different natures. Among them, we can find lithogrammetric or photogrammetric 3D point clouds, pictures, drawings, but also restitution hypotheses, 3D meshes, semantic annotations from IOLI, chemical analysis, spatialized sound samples, and so on. So finally, this context raises some issues in terms of exploration and manipulation, since in view of all this diversity, the manipulation of each data would theoretically require the use of several specific software, and it would obviously be a big problem in terms of accessibility, and most of all, it would considerably reduce our capacity to cross the views between actors, whereas this project is highly multidisciplinary. So to address this issue, we developed a 3D web viewer. So it's based on the awesome Pottery.js library, which is developed in the Vienna University of Technology. So the Notre-Dame viewer is accessible from a simple browser to all the project's members. The aim of this viewer is, first of all, to centralize and spatialize in a common reference system all the data related to the monument, whether they were produced before or after the fire. So here the keyword is really to make easier the access to the data and knowledge produced all along the restoration, but this aggregation of resources must also facilitate the cross-visualization of the elements produced by all the working groups to help to identify potential correlations between different analyses, between different observations, between different disciplines. And to do this, the very first step is to proceed to the spatial registration of each data in a predefined coordinate system. This operation is performed upstream before the web visualization, and it's not yet automated. Sorry. But in any case, once the spatialization parameters are known, the data can be loaded into the viewer, and it's done while maintaining a permanent link with ArcheoGrid. So remember, ArcheoGrid is the indexation tool allowing to manage all the description of each file, provenance, nature, decision, and so on. So in this way, each element loaded into the viewer is always linked to its metadata, and thus also to all the vocabulary terms that were used. And it would facilitate the exploitation of the data and ensures in a certain extent its traceability. This illustration is quite old, so at the moment of this screenshot we had not so much metadata, so maybe it's not the best example. And of course, each element can be displayed and hidden freely by the user, but to simplify the navigation and make it more intuitive, the cathedral space had been segmented into different volumes, following the nomenclature of spaces in use for the restoration and predefined in OpenTeso. For example, the user can choose to display only all the elements concerning the choir, or more specifically, the tribune of the apse, or even more specifically, the tier 1 span. So in this way, we can offer a first filter driven by users' interest. But here, it's only a filter by spatial proximity, but the really same logic could be applied to all the metadata to build this time a filter by documentary or semantic proximity. For example, if I want to display only the elements produced by a specific person or at a specific time or representing a specific phenomena. So the viewer is also directly connected to IOLI, the tool dedicated to semantic annotation. As shown by Roxane, several projects were carried out on IOLI following the diagnosis made by the architects in charge of the restoration. Well, all these projects and the several thousands of annotations can be loaded directly into the 3D viewer, which is particularly interesting to contextualize, but most of all to confront the observations made by several actors, for example, made by actors of the scientific project and other annotations made by actors of the construction worksite. And also it's useful to track a phenomena on different temporal states before or after the fire. Here you can see several IOLI projects manipulated into the viewer. In this video, only projects data are activated, so all the other resources of our corpus are hidden, but they obviously can be superimposed with any other Notre-Dame data, be it laser grammetric 3D point clouds or 3D restitution like here. So descriptive sheets associated with the annotations are also loaded as metadata. So as I said before, one of our targets would be to improve the exploitation of this information, to be able to filter the elements visualized in 3D, for example, to display really quickly all the stones that need to be replaced. Well, I won't talk about the interaction tools because they are quite classical, and the majority comes from the native great functionalities of Potri.js. In fact, for the interactions, the challenge was mostly to propose some ready-made parameters, some kind of texture or manipulation presets intended to facilitate the analysis in very specific contexts or by specific persons that were not familiar with 3D visualization and navigation. However, it's obvious that the needs of the restoration site evolve over time, so we make the viewer evolve accordingly. For example, what you see here is the beginning of a work done with the Metal Working Group on the loading of chemical analysis. So they provide us with an Excel file containing different samples they analyzed, and each one is located in 3D by a simple triplet of coordinates, and is also associated with a list of quantitative values characterizing its chemical composition. So these measurements are loaded into the viewer as shapes in the 3D scene, and the corresponding data are represented in the side panel as diagram for better understanding, with some options like choosing between linear or logarithmic scale, go to the 3D position of the analysis by double click, and so on. And in addition to the fact of just locating them in space, the interest of loading this kind of data in the viewer would be especially to allow to filter the display of the samples with thresholds. For example, to display in 3D only the samples whose lead content is higher than a given value in a specific area of the monument or anything. And in the same state of mind, we are discussing with the company which handles the sensors used for the monitoring of the cathedral over time to load it into the viewer using the same logic. And I think it would be a great opportunity to think about 2D, 3D analytical visualization tools. What you see here is the work done with the Stone Working Group Anais talked about. So the goal was to realize the anastylosis of the collapsed transverse arc in the nave. And what you see in white is the theoretical parametric model of the arc. It was made using pre-fire data. And in the same time, the arc stones found in the nave after the fire have all been digitized in 3D. So from there, we were able to test different localization hypotheses by placing in one click each arc stone on a theoretical position, with also the possibility to quickly invert the backside and the front side of the block, or to change the color to show the uncertainty of the hypothesis, and so on. So here I take this block and I move in on the R54 position. Okay, or maybe you understood the principle. So 3D op shown before by Marco helps to observe the stones itself at a small scale and to understand how their specificities can give information on their spatial localization. And this anastylosis tool helps to test and possibly validate the hypothesis made from all these analyses. And of course, it's possible to export a synthesis table of the hypothesis. And the same approach could be applied to many other study cases on the site, for example, rough structure remains. But maybe I can move on. Okay. And to finish with this example, I think the arc stones are a really interesting case study in terms of visualization and manipulation, because we know for a part of them their post-fire position, but we also have some hypotheses of pre-fire positioning. So finally, each block is associated with several spatialization information. But in this case, which one do we use? And to answer to this kind of situation, we set up a kind of temporal slider that you can see here. It allows to change the position of the block in the course of time. So here you can see the N1A stone, which returns back to its pre-fire position. So we are virtually moving up the arc. Obviously, it raises a few problems. First, because we have to interpolate the known positions to deduce a trajectory, which does not correspond to any physical reality. On the video, you can clearly see that the block crosses the wall. Here, no. And also because it raises important matters in terms of temporal granularity, since to go further, we would have to be able to characterize chronology and the scale between different ways of expressing a time, a moment, and so on. So today, this work opens interesting perspectives in terms of analysis, since the corpus we managed to create in this way will allow us to introduce new data multidimensional correlation mechanisms, taking into consideration at the same time the notions of space, of shape, but also of time, and of course of knowledge domains through the analysis of the semantic relations that can be established between different concepts. So here the idea would be to set up some mechanisms to build new semantic or geometrical interconnections between data and concepts, and thus to try to characterize some links between actors or some links between disciplines mobilized on the project, some links between the observed phenomena to detect possible occurrences, synonyms, and why not even causal relationships. So the goal would be to be able to provide exploration and interrogation tools that would be able to take advantage of all the quantitative and qualitative information accumulated within the very same environment. On this point, there are many interesting things to explore, for example, to enable multi-criteria queries, such as this one. I wish to visualize in 3D any resource representing a vestige whose length is greater than 1 meter, found in spaces bordering the T22 span and prior to the June excavation. So, of course, this example is purely fictive. It was to give an idea, but it's clear that it is complex in that it includes several criteria of very different natures. First, we have a documentary criterion with any resources, which gives us an indication of the file types expected in output. Here, any type. And then we have a semantic criterion, since the extracted resources must be linked in one way or another to the term vestige, which implies being able to define precisely what this concept refers to, what is a vestige, and which concepts are close or similar to it. Then we have a geometric criterion, which gives us limits on the dimensions of the projection of the vestige in the 3D reference system, which necessarily implies being able to set a link between a semantic assignment and a geometry. We also have a spatial criterion, which gives a precision on the relevant span, which implies being able to define precisely the nomenclature for spaces and shapes, and most of all, the hierarchical relations between the elements resulting from this division, and also, obviously, to be able to control the spatial referencing of the corpus elements. And finally, we have a temporal criterion, which requires several things. First, to be able to date all the resources, which raises a question of granularity, as I said, and also to be able to do it in an harmonized way, relying on the shared and the stable temporal division. And it's really not trivial. So I have not so much time left, so I will finish here, but basically the idea would be to rely on a kind of meta-knowledge model to build a big graph synthesizing all the information related to the project, whether in terms of spaces, shapes, actors, and so on. And it will have to be continually updated through correlation mechanisms that will constantly seek to define new relationships between the nodes. And then the joint exploitation of this graph and the capacity of 3D rendering engines in terms of geometrical analysis should allow to execute quite fine queries on the corpus from both quantitative and qualitative criteria, and eventually to describe new informational spaces, to propose new exploration modalities, be it based, for example, on intuitive expression modalities like natural language or serendipity. So here you have an example of a first graph we made from the nomenclature of spaces and shapes. That is in use by the architects in charge of the restoration. And here you can see a graph made from all IOLIS projects. So it contains all the diagnosis observation. It's clear that we can already perform some very interesting rewires on it. On this animation, I was just looking for the nodes associated to the stained glass concept. But a challenge is now to connect it to all the other graphs concerning Notre-Dame. I mean, to the nomenclature graph, to the vocabulary, the numbers, and so on, to finally be able to answer the kind of questions I just mentioned before. Well, it's a work in progress, which is really exploratory for now. So we started to have interesting results, but there is still a lot of stuff to do. But I think it could open up interesting perspectives, not only for the continuation of Notre-Dame's project, but also to better understand the mechanisms that lead from data to knowledge into different communities around the very same cultural heritage objects. Okay, I'll pass on this. So thank you. I hope I didn't took too much time. Thank you very much for your attention. And if you are interested, you can find some videos to deepen some topics that were mentioned today on this website. Thank you.
Thank you very much to all four of you. It was dense and intensive. So you get our applauses here. I don't know if you can hear them, but let's have few questions. We don't have too much time left, and Professor Zyda is waiting for us as well. But let's have some questions. Yes.
Hello, thank you. The talk is really impressive with attention to detail and all the work that the restoration of Notre-Dame has kicked off. I've got a question for Violette, and it's around the data formats that you're using. So you have a tremendous amount of data in point cloud and mesh formats, some very large data sets that need to be registered together and then visualized over the web. And how do you overcome the problem of the sheer size of the data and the volume, and visualizing that over the web? So in terms of the kinds of data formats that you're using.
Violette, did you got that question? So what about I saw your face. So what was about the data format that you are using, knowing that there is a huge quantity of data that you have to move over the web?
I'm sorry, I didn't hear the question. Maybe it's. I hear you better when you speak in front of the scene. I'm really sorry.
Okay. Then I will use another microphone. Wait. Just.
Can you hear me better now?
Yeah, much better.
Okay, so the question was about the data format are you using, and I suppose that is not only the format, but also knowing that you have a large quantity of data that you are visualizing on the web. What kind of data format are you using? What kind of representation technologies?
Okay, so we tried to privilege standards as possible, or at least some ASCII files to be able to keep the possibility to open the file in 10 years. For the point clouds, we used mostly PLY. And for the meshes, we used file format proposed by the Visual Computing Lab of ISTI, to be able to visualize the meshes with Nexus libraries.
Okay.
But all the point clouds had been converted to be loaded into Pottery's viewer.
Yeah, which has view-dependent rendering by design. Yeah. Okay. Other questions or comments from the people online? Let me check the discussion. Okay, no other particular question. Okay, thank you all. We have to close here the workshop. But thank you a lot for all the material. I don't know how much of this material you can make public, but that would help a lot the people to have some insights from what you presented. So if you can prepare a presentation that can be, of course, not public, but shared with our participants. Thank you. Thank you all.
Thank you.
Good.
Thank you and goodbye.
Bye bye. Bye. Oh no. Don't bye bye. Stay here because we have a keynote. So let's go directly and introduce Professor Zyda. So he is with us from US, but he is during the day, so that is good. We didn't ask you to wake during the night as Dawn did it from the last night. So you may be already know Professor Zyda. He is professor in the University of Southern California, but he is more known to be one of the fathers of the game program, teaching program, and many of his students created later on games that were very, very well known. So I don't want to take more time. I give you the screen, so just make a test that you can display your screen, and we cannot hear you.
I'll share my slides.
Yes,
see if that works.
So, but we can hear your voice, which is already good. We can see your camera,
okay,
which is even better. And now let's see if we can see the slides.
Let's see, slides. There, that would be good.
Okay.
Where did my slide? You can't see my slides.
Yes, we have your screen.
You see my slides. I didn't see them. Hold on here. All right. Okay. All right. So you can see the one that says, let's rename everything the Metaverse.
Yes.
Excellent. All right.
We can see the slides in editing mode. I don't know if you want to present in editing or...
I'll put the replay mode. Sorry about that. How about that?
Great. It's full screen now.
Excellent.
The floor is yours.
All right. Thank you. Hi. Name of the talk today is Let's Rename Everything the Metaverse. And this is based on an IEEE computer article I wrote in the last year of the same name. And a little bit about me. I'm an ACM fellow. I'm an IEEE fellow. I'm a professor of engineering practice at USC. I'm advisor to 11 plus startups globally, and I'm the games editor for IEEE Computer. And my website is Zyda.com. If you want to go find any of the IEEE papers, there's a whole section of them there. So let's start out. And the Metaverse is a term created by Neil Stephenson in the book Snow Crash. And I read this book when it came out. And the first use of the word metaverse is right there in the book, and I'll read it to you. It goes on the back is gibberish explaining how he may be reached. A telephone number, a universal voice phone locator code, a PO box, his address on half a dozen electronic communications nets, and an address in the metaverse. Stupid name, she says, shoving the card into one of her 100 little pockets in her coverall, but you'll never forget it. So the very first time the word metaverse is used, it's listed as a stupid name. All right. But, metaverse is a portmanteau of meta, meaning transcendent, and verse from universe. This is from an article in The Conversation in 2021. I like portmanteau. It makes me think of traveling salesmen with large suitcases taking trains to distant cities to sell their wares. And so that is what the metaverse is becoming, a place where salesmen will come to sell their wares, virtual and real. And everyone is rebranding their games as the portal to the metaverse. So the biggest problem we have now is all of these new metaversi, I'm not sure if that's the right term, they're not connected. And if all your efforts go into building your personal virtual identity inside one platform, you could find yourself friendless and stranded inside the modern equivalent of MySpace, or even worse, Friendster. Those of us that started early in the network virtual environment realm wanted an open world, a world where your avatar could be anything, and you could move between parts of that world for free and unencumbered with commerce, kind of like how the internet started and how all of the Web3D people have always thought. But as we know, the internet did not stay commerce free for long. I mean, it was this weird period when people started doing commerce on the internet, and people kind of were using the old model, which was you can't do commerce on the internet. And that kind of lasted about a year. And the internet became this space where you had to choose your own walled garden. And I like to think of this as the generalization of America Online, if you remember that. AOL was a walled garden that initially you dialed into with a modem and received all your news and communication with your friends and commerce inside. So you could talk to your friends in AOL, and that was it. You could see news inside of AOL. It wasn't really until the internet with web browsers and web pages that we kind of could go pretty much anywhere we wanted to find the community of our internal desire. I remember, I think it was March of 1994, and Don Brutzman came into my office, and he goes, "Mike, I've got to show you this piece of software called Mosaic." I said, "Don, go away, I'm very busy." And he goes, "No, I've got to show it to you." And he insisted I look at it, and all of a sudden, in my mind, I said, wow, this is how I could go find information. Awesome. So with the prominence on the internet of social media platforms like Facebook, Instagram, Twitter, which is maybe dying, we all go back into a walled garden once again, all seeking solace inside. And everyone wanted to climb back inside the comfort pioneered initially by AOL and the like. So we can look at social media platforms as everyone wanting to again rebuild America Online. And with the various metaverse platforms being created, we're all considering climbing back inside of AOL's replacements. Now, every online game made that has had any success is rebranding itself as a portal to the metaverse. We can kind of see what is being built. We can see that these worlds are 3D, that each world is providing users the ability to stylize and create their own 3D avatar, and the ability to create and develop their own island, space, games, imbued with gameplay, social communication, and commerce. And we wish them all well, and most of all, we wish them all the ability to allow their users to transport their avatars, worlds, businesses, friendsless between each other. Not too likely, though, as walled commerce is the AOL model they are all following. Oh yeah, this disc. One time I wanted to collect enough of these discs to have all of the hours of my life, but I never succeeded. So Second Life gets a second life. Let's look at it at a predecessor metaverse that had great potential, but never could get much past the slap together without art designers look. Let's look at Second Life. And if you look at Second Life, it kind of looks like this today, which is sloppy, very sloppy art. Now, first of all, I would remind you, I'm a tech person, and I was totally enamored at Second Life's ability to gather some 900,000 users into its virtual world, despite having a dreadful user interface in its client, and despite having a mid-90s rendering engine that made everything look like engineer art, which we all know is a technical term for a sucky look. So with the 2003 launch of Second Life not being too far from the mid-90s, it was not too surprising that it looked that way. Second Life's developers completely had no clue as to how to provide a good user interface so that its users could easily move through and interact with its various user-built worlds. And despite this weakness, Linden Labs, the developer of Second Life, showed a $3.2 billion revenue over a 10-year period that was made from user-built businesses inside the platform, as well as the sale and purchase of virtual real estate inside the world. Second Life even had its own in-world currency, the Linden dollar, which had this come out in this era as Bitcoin or some other cryptocurrency, would have made them the bomb. And the most amazing thing is Second Life still exists. as a platform and could still do this, and we'll just have to see. All right, let's talk about Epic's Fortnite. Epic is a successful company that, when it is not spending its investors' money suing perceived competitors for lower platform fees, it has a great future ahead when it finally unwinds itself from the legal morass of its own making. And Epic's Unreal Engine is beautiful. It has been beautiful in all the years I've seen it used to make some of the most wonderfully successful games. I even licensed the Unreal 2.0 Alpha engine for the America's Army game back in 2000. We had to add 150,000 lines of C++ code into that engine to make it work for us at the time. And I'm sure the engine is way easier to use now, and maybe you don't have to add that many lines to fix it. So Epic's entry into the Metaverse space is to take its Fortnite game, a hugely successful game that used to be on more platforms, and make modifications or mods accessible to users by way of its Fortnite creator toolset. So users can create their own island, build their own games and businesses on that island, build their own communities, and share revenue with Epic as their games, communities, businesses in the Fortnite metaverse become successful. It is a second life with better development tool sets, better user interfaces, and way better rendering. By the way, every single platform that's coming out and saying they're a metaverse portal is telling you can build your own games inside. And the only problem with that is, do you know how to build games? And then do you know how to use their tools to build games? So a couple of problems. When Epic settles its legal issues, say 5 years from now, it will be on even more platforms and make its developers even more revenue. And we wish them the best of luck as they have the best look and best capabilities. And Fortnite, if you look at this is absolutely beautiful. All right, Meta, Facebook, Horizon Worlds. Facebook is a direct descendant of America Online, and is a walled garden or island, depending on your taste and metaphors, that encloses you in its newsfeed algorithm and presents you with the most provocative postings during your daily or hourly time there. And Facebook hopes you will post your most juicy daily life issues online so that others can respond, fight, like what you say, despite your personal truth-resistant narcissistic cravings. Okay, a little bit too much maybe. I like Facebook for this. It's kind of the epitome of algorithms gone wild, and is letting us all know at this stage of our development that perhaps we need to be more careful with what we build and then ship, or what we say and then type into Facebook. And Meta is under investigation by Congress for its tacit participation in the 2020 presidential misinformation campaign and the January 6th coup attempt by the outgoing President for Life hopeful. So Facebook is building its own entry into the metaverse named Horizon Worlds, now with a renamed company called Meta, which, if you recall earlier in this article, it means transcendent. And transcendent of what is the question? Perhaps it is Facebook's way of saying they're running away from misinformation and coup assistance as a business, while Twitter moves towards that. That would be an appropriate use of their Luca. We will use Horizons as the name of their Metaverse entry rather than the cumbersome Facebook Horizon Worlds or Meta Horizon Worlds. And Horizons is a 3D social space meant to be run inside of the Meta Quest 2 VR headset. I love this headset, by the way. I have been playing all of the fitness games in the last week. Meta has other VR apps besides Horizon and has a huge number of users in their Facebook, Instagram, WhatsApp platforms that might transition to Horizons if they can find enough engineers to make this happen. There is a major shortage of people and of engineers and engineering talent that knows how to build things inside of a 3D virtual environment with a head-mounted display. Now we might say only 50, as we say might, as only 15 million Quest VR headsets have been sold in total. So if you were a game console and only sold 15 million game consoles, the company with that game console, if it was Sony or Nintendo, would cancel that console. But Meta is going full steam ahead. Meta itself has 2.89 billion users on its Facebook platform, so approximately 0.5% of Facebook's users are using the Quest 2 headset. Meta has made 86 billion in 2020 in revenue, primarily from ads, and this year has lost excuse me, some amazing amount of money due to their focus on the metaverse. I think they're spending $3 billion per quarter approximately. But Meta is building their metaverse with their Quest 2 VR headset, which means that most people won't join this metaverse as who wants to wear an HMD for more than 3 or 4 minutes. And maybe that will change. I've been playing some of the fitness games on the Quest 2 and get all the way up to an hour before I have to take it off. And Meta still has a continuing problem with Congress, so we don't think there is much future in this until Meta figures out how to do a VR-like experience without an HMD and figures out how to make its algorithms less provocative to Congress. And if you look at some of the pictures of the Horizon world, they look actually pretty good. Roblox is another entry in the Metaverse. It allows the user to create their own avatar, create their own games, play games of others, and make revenue in Robux, which is their currency. As of August 2020, Roblox has had 164 million monthly active users, which is way better than any other Metaverse portal, I think, at this time. The images online for Roblox show an artistically developed world that continues with its avatar creation system. And if you look at what they've got, it's absolutely the best, also gorgeous, like epic. Minecraft is part of the Metaverse. If you really can stand the Minecraft look of digital artifacts, I don't. And in fact, this is a slide I took from John Radoff. He said I could use it. Everyone is part of the Metaverse. So if you go and look at this slide, you'll see that there's companies in infrastructure, there's companies in human interface, there's companies focusing on how do we decentralize everything, there's companies that do spatial computing, there's the creator economy, there's discovery, there's experience. The Metaverse is tons of companies right now, according to John Radoff. And the Metaverse University, everyone jump into the pool. This is a one slide proposal I wrote to build a brand new university that focuses on how do you build the metaverse using all of the various metaverse platforms out there. So there's a metaverse development track, which is sort of like an engineering of metaverse track. It's got metaverse design workshop, 3D computer graphics and rendering, metaverse platforms and tools, metaverse modeling and simulation, metaverse networking, infrastructures, machine learning for the metaverse, and my favorite course, building the human intelligent metaverse. There's a metaverse design track. There's a metaverse art and design track, and the art and design tracks are pretty much focused on sort of traditional 3D art that you can actually get at many places. But the idea is to build a metaverse university that has all of these people working together to do advanced metaverse projects over a 2-semester long effort and have a direct connection to an incubation and acceleration center for metaverse and technology startups. So there's a number of people that I'm talking to about building this new metaverse university. We used to call it the internet, but now we have a new term because this is in 3D and allows us to create cute 3D avatars with outfits changeable daily. And most of the metaverse rely upon game networking infrastructures and a game lobby where the player selects what world, island, garden the player wishes to teleport to. So if you went into Oculus Quest 2 today, you would get into exactly a portal into a game, into a very selection of apps you could play. So worlds, islands, gardens can be treated as levels would be treated in an online game. They can use the same technology, and most of them will require that you pop back up to the lobby when you want to switch worlds, islands, gardens, or apps, and go through some sort of portal inside a level. There don't seem to be any real open worlds except perhaps Second Life because it was built that way. In Second Life, it was architected so you could walk from one virtual property to the next. And the only real issue then is how many servers are used to manage any one level and maybe have an architecture to expand or contract when the numbers of players in a particular level expand or shrink. I'm going to show you a couple of figures. Figure 4, which is the next slide, shows what a traditional client-server game architecture looks like. And it looks like this, is you got your clients, they have to connect to an authorization server. The authorization server checks accounting, make sure they're current. It checks their player persistence database to see where are they so far in this in this game, and then it assigns them to an appropriate game state server. So this architecture is replicated by every single network game company out there in the world. And the next figure 5 shows what we really need to do if we want a virtual space to accommodate, say, the number of players that attended Woodstock. For example, say 400,000 spectators, players that can walk from one end of the farm in Bethel to the other without having to transit a game lobby. And then that's how it will go if we create a single metaverse properly and not just make it a marketing term for games that allow character mods, which is my serious comment right now. So this is a picture on scalability in a single metaverse organized by virtual space. So it has this notion of P of I persona. I'll tell you what persona is in slide 6, but basically think of that's your avatar and that's your state. And you connect to a particular SMI. An SMI is a server maintaining a part of the virtual space of this particular metaverse. So if you start in the lower left-hand corner and you're P of M and you're in the space that's modeled by SMI, by server SMI, you can start walking. Let's assume that you can walk to server S2I or SMJ or whatever, and that will give you a new piece of territory. And if you turn around and look back, you can see in lower resolution the server you just left, or a little piece of the server that you just left. So if you're going to do scalability and make it so you can walk across your whole individual metaverse, then you'll have to think of an architecture like this. If we want to move between different metaversi, I mean, this means walk from Roblox to Fortnite, then you need something like figure 6, which is coming up. And figure 6, we see in open worlds and an AOL-like walled garden. Open worlds can utilize a persona, which is a 3D avatar, your friends list, and additional data that may have been created in another metaverse so that we can bring our cute 3D avatars along with our friends, pretty please. And trying to bring that friends list is going to be like the biggest war ever, I think. AOL-like walled gardens are not at all what most of us want, and we want to be able to free to move easily among the metaverse. I don't know if many of you remembered, there was a period when Facebook was really big, and then Google came out with Google Plus, and everybody started to jump to Google Plus, and what they discovered is they had to recreate their friends list all over again. So most everyone gave up and went back to Facebook at that time. So this is a picture. This is connecting the metaverse, which is, you know, the walled gardens have the solid line around them. You've got metaverse I, you've got metaverse J. Let's say I is Fortnite and J is Roblox. I can't walk between these, all right? I can just go into metaverse J and stay in there and play and do whatever I want, or I can go into metaverse I, but I cannot walk between them. If we want to have open worlds, then metaverse K and metaverse N, we can walk between them because we're going to have this notion that there's a persona, which is a 3D avatar. Maybe it's our collection of 3D avatars. You know, we can change clothes all the time. It's our friends list, so that when I go from metaverse N to metaverse K, I can contact my friends from there, and, you know, also whatever else needs to come, which might be any data that you create in a metaverse, any purchases that you make, they're in this piece of structured data that you bring with you or you have access to, right? So what will happen to games that don't rebrand as Metaverse? If you believe the path of the Metaverse is the truth, the way, and the light, then games that do not rebrand as members of the Metaverse will all die a slow and miserable death, a death prognosticated by the Metaverse version of the Metacritic, perhaps the Metaverse critic. All right. Blockchain, Web3, NFTs, whenever I mention to people that I'm planning the creation of a new university, the Metaverse University, I either get great understanding from real tech people who have been in the 3D virtual environment space for some time, or I get the blockchain, Web3, NFT fanboys or fangirls who telling me that the Metaverse is just about Web3 and how they will soon become rich beyond their wildest dreams, and asking me what I think about crypto. So I usually delete any person who chats with me on crypto online, but I believe we should perhaps study the whole blockchain, Web3, NFT space to see if there's some nugget that is not fully and foolishly useless, all right? This is This is a strong opinion I hold, but it's held by lots of people in the game industry. So I put some comments from Gabe Newell, who's the CEO of Valve. I put 2 comments that are right out of Forbes magazine from this year in February. And this is Gabe Newell on the blockchain and NFTs. And the things that, and initially, Steam was allowing blockchain and NFT things into Steam. And he says the things that were being done were super sketchy, and there was some illegal shit that was going on behind the scenes. And you're just like, yeah, this is bad. Blockchains as a technology are a great technology, that the ways in which it has been utilized are currently all pretty sketchy. And you sort of want to stay away from that. The people who are currently active in that space are not usually good actors. Here's another comment that I liked. There's a bunch of get-rich-quick schemes around the metaverse. Most of the people who are talking about metaverse have absolutely no idea what they're talking about. And they're apparently never played an MMO. They're like, oh, you'll have this customizable avatar. And it's like, well, go into, I know, say in Final Fantasy 14 and tell me that this isn't a solved problem from a decade ago, not some fabulous thing that you're inventing now, which is pretty funny. Another article entitled "The Boom and the Bust: How NFTs Went the Way of the Beanie Babies" is also worth reading. It came out in September in ArtNet. It goes, in early 2021, NFTs were pitched as a way for artists to make life-changing money. All you needed was a token, so artists raced out to buy Ether so they could mint NFTs of their work. Only the money didn't pour in unless your name was Beeple. Now all that is left of the once overly hyped NFT market is dust in the wind. NFTs are becoming an unattractive piece of history. People aren't trading them, and the only ones talking about them are those trying to sell them. All right, another article. NFT trading volumes collapsed 97% from January peak, and that came out in September in Bloomberg. So on one of my presentations to NVIDIA on founding the Metaverse University, I had a slide in our proposed adjacent research institute. And NVIDIA's comment was that they all thought blockchain, Web3, NFTs was all just a big scam, and that I should take that off my research slide. So I think I'm going to leave it on my research slide so that it reminds me that perhaps I ought to take a closer look, just in case there is a winning lottery ticket inside. Oh, this is a great day to talk about winning lottery tickets. Powerball is tonight. So this is the Metaverse Research Institute that I put out there, and you can see it says NFTs in the metaverse because it's a research issue, which is we have to figure out, is this real? Is this something we should think about? And we've got to have some understanding of blockchain and tokenomics and be able to come out from our research institute and say, yeah, maybe look at this. Human intelligent metaverse, there's this notion that natural language processing now works pretty darn well, but we want to have sensors that can read our emotional state, that can be used to build AI characters that have personalities and virtual emotional states and virtual mental states and virtual physical states, such that we can do interesting story creation and understanding with deep learning systems. Metaverse economics, we've got to have in-game currencies, we've got to have a monetization scheme, and everyone points towards, NFTs and blockchain. AI infrastructure for the metaverse, machine learning-based metaverse engine architectures. There's the whole notion that most of our game engine architectures right now, some of them are tacking machine learning architectures on the side. But there may be a requirement to actually re-engineer game engines so that machine learning is a first-rate designed-in structure. And of course, networking, metaverse networking infrastructure and standardization is pretty much what I was talking about in a couple of slides back. You've got to think about 5G and 6G architectures, for this, because a lot of the places where people are going to go into the metaverse are going to be in the mobile space, not necessarily in the head-mounted display. And latency is sort of your classic issue in networking, and metaverse streaming architectures will have this in spades, because once you start building 3D characters and having them talk and pass things back and forth in 3D, then you probably have huge latency problems. Metaverse design and creation is another research topic, both for AR and VR, and experience authoring tools is key in both of those, because we can't just always start from the game engine side. We have to actually be at a platform level above that to make it so that metaverses can be built quickly. We also believe that when you get to virtual reality, that there are ways to do HMD-less metaverses without head-mounted display. In fact, I am a co-author of 3 patents with Peter Jokaras on this, and we've got a great idea how to do it. And we have a startup, athanos.com, that has that going. So, but it's still a research topic to see if people want to do it. And you're obviously going to see a lot of lightweight AR glasses come out from companies like Apple and Google, probably in the next year or so. So that's our research institute for the metaverse that is part of the Metaverse University that we plan. Okay, here's some references, the things you should look at maybe for additional information. There is a 2005 paper that I put into IEEE Computer called From Visual Simulation of Virtual Reality to Games. And if I could just reach out and grab the paper, I would add to the metaverse. But this is sort of that talk. There are some other things to read. And if you haven't read Neil Stephenson's 1992 book, Snow Crash, you should. It's great. I like his book, Diamond Age, a whole lot better, though. Things to read from IEEE Computer. Next, in this month, patent litigation, the game states will come out. Last month was building a human intelligent metaverse, which was my attempt to architect a metaverse where you actually could read human emotional and mental state and physical state such that you could interact with AI characters that had virtual human and virtual physical, virtual emotional, and virtual mental states that you could interact with. I also put out a paper on weapons of mass destruction, America's Army game in 20 years. That game played for 20 years. Also, we need something like Bell Labs for the games industry. And of course, Let's Rename Everything the Metaverse. And another paper you might want to read is Will I See Sensor-Based Games Happen Before I Die, which is sort of the underlying thing that you have to do before you can actually get to building the human intelligent metaverse. All right, here's my email address, and I'll I'll leave that up there for a couple seconds. But maybe what I should do is get back to the picture of me. How do I turn off sharing? Where is this? I got to go pop back to this. So I want to go back to Web3D. All right, how do I turn off sharing? Okay, I didn't see. I'll take questions at this time.
Yeah, okay. Let's open the floor for some questions.
How do I turn off sharing so I can see people?
Yeah, what we can do, actually, there is another screen that is filming part of the room. So it's called Web3D 2022.
Oh, I
and
see.
You can see people there, some of them.
Got it. I found my way back. All right. It was in the lower right-hand corner.
Okay. So let's have some questions from people online. Let me check.
I can see someone in the back there.
Yeah, Patrick will.
Athanos.com, athanos.com.
Yeah, I was wondering about 3D body scanning and all that. Are you looking to bring any of that into the metaverse at all, or you're only focusing on games?
I'm
I'm
having a hard time hearing your, can you repeat that? It's very muffled sound.
Yeah, maybe if you take the other microphone is better. And try to keep it as close as possible. Yeah. In the meantime, maybe you can answer to the question, what was the name of your startup with the non-HMD immersive 3D?
Athanos, athanos.com. Okay, ask your question again.
Okay, I'm gonna try one more time. I noticed that you're focusing on games only. I was wondering if you were looking to focus on any retail products such as apparel, footwear, such that you take a scan of somebody and you develop product, are you looking at any of that, or is that not part of the the Metaverse University?
No, the Metaverse University, it really is going to allow people to work in any of those spaces you want, you know, because there's a lot of design work for clothes and apparel. I live about 5 blocks from the Fashion Institute for Design and Manufacturing in downtown Los Angeles. So most of the people who live in this building work in the fashion industry, and I don't know why I live here, but I'm a computer scientist. But the answer is yes, and I also think there's huge medical uses for the metaverse as well. There are so many uses for the metaverse. The real question is, how do we get people to learn how to build metaverses so that there's actually talent available?
Right, but I guess my point is if you don't have that as part of the university and there's distinct needs in terms of medical or health or apparel that are kind of different than what you've shown, then they don't have that skill set related to that focus.
That's true. When you go and build your own university, you start with one. We build it with the technology for building the metaverse first, and then I think what our plan is to attach or do an agreement with a university that has a medical school, that has a fashion design program. And in fact, the real thought we've had has been to connect to multiple universities from this Metaverse University so projects can work well there. All right.
Okay. I have one question. You showed this slide with metaverses that are islands or versus metaverses that are interoperable. And what you extracted on the bottom side of the slide was the avatar and the list of friends and some other, let's say, user-related data. But yes, we know today that online games are making a lot of money with exactly that data. And right. How to make them change this way of...
Well, so you notice I put it inside of your persona. So yeah, if your data is inside of a persona that is defined by you, then what can happen is if the companies want access to that data, you can sell them access. All right.
I'm referring more. Let's take the example of Fortnite with the skins. This is how they make a lot of money, and they would like to keep the control in how you have the skins for your avatar. So I imagine that you take that skins to another metaverse. You cannot use them as they are because they are produced by someone else. Do you think about the kind of transcoding where I will go naked from one game to another and just have to buy skins from anyone?
Well, you know what? There is a group called the Open Metaverse Group, which is trying to figure out how do we make the avatar thing is a simple thing, which is if you want to build 3D avatars that can work in all kinds of different places, all it requires is somebody builds an SDK that allows you to take that data to any of the other metaverses that are out there. Some of the other things that your friends list, that can be easily in a standard form. But the other miscellaneous data, well, some of that data is going to be pertinent to Fortnite. Some of it's going to be pertinent to Roblox. Some of it's not going to be usable by those other places unless there is some kind of XML-like way to interpret what's there that makes sense. All right.
Okay, Anita.
Thank you for your insight. Your speech was excellent. Can you hear me?
I can hear you, but the microphone is very muffled.
Is this better?
Just don't put the microphone right against your lips. Just put it a little bit in front. Maybe that will work.
This is better. Okay, so my question is, what are your thoughts about accessibility, usability, and safety?
About usability?
Yes, and safety.
And safety, yeah. Well, this is a good question. In all these virtual environments right now, when people build them for a particular platform, what you do get is sort of a set of ways to standardize the user interface for that platform. So if you build stuff for the Quest 2, there are some pretty good standard user interface things you can get to support your work there. But terms of, let's say I want to all of a sudden build something for the Vive, that transition is not usually very easy. With respect to safety, yeah, I live alone in downtown Los Angeles at the moment, and so when I go and do physical fitness games, I know I'm not going to crash into another person, and I push the furniture away enough so I know I'm not going to hit it, and there is basically a virtual safety wall that you have. But people have to worry about that.
Okay, we have some questions in the chat window, so I will read them for the people here. So a question by Don saying, are gaming business imperatives as World Wide Web interoperability resolvable in the metaverse, or more like whale plus water and never really mix?
Well, that's a great question, but I mean, I think the answer is fairly obvious, which is the game industry, for the most part, makes its money just like I said, AOL, which is glue you in to our structures. You know, it's funny, the biggest lawsuit that Epic has is against Apple, claiming that Apple is a walled garden, and what it really wants is Epic wants to be the walled garden to collect the money. So I think it's you know, I'm not sure if they will all join the open metaverse. More likely, companies like NVIDIA. NVIDIA has some really great people who are thinking about, who are basically the pointers to the open metaverse. When I gave my talk on the open metaverse, on the Metaverse University to Michael Cass, if you know Michael. And Michael's basically, I think, the architect for their Omniverse. And he had some great guidance as to, you know, how you do this in open fashion. So he's a wonderful guy. So I think some of the tech companies will get it. The tech companies that are not connected to game companies, all right? Game companies, I think Unity will provide a way to do transitions better with their engine than the Unreal Engine. Also. Okay. Next question.
From Nicholas. I let you read it. If you how do we protect personas and medical data in the metaverse?
Well, I think you know, the reason I drew that all as persona is something you own, that you're going to have some encrypted version of that, and it's going to be a public private key system, right? Which is, you know, if you have someone you want to give access to that data, you'll have to, you know, get them a key to your data. But other than that, people can't just crack it. So it's security becomes a really big deal. You know, a lot of people in the game industry historically put in security after they've been hacked. But you know, as you become older as a game company, let's take Activision. Activision, with respect to their online game infrastructures, has thought about security since the founding of Activision, and so very rare to see any hacks on Activision. But if you look at a company like Nexon, I got hired to be an expert to help Nexon with the issue of people were cracking their games, Combat Arms and MapleStory, and it turned out they hadn't bothered to encrypt their packets. And as soon as I told them that they needed to do that, they said, "Oh yeah," they fired me. I thought it was pretty funny, actually. But what can you say?
Okay, so the technology exists, people have to use it properly.
They just have to use it. They have to want to do it. They want to have to pay. The security, you know, the people who do security are super highly paid. And you know, in the game company, they're trying to do things on the cheap. Let's not do it. And also, you know, Nexon is a company that's outside the United States. They may not have access to all the security things that are available inside, right? Or in Europe. Europe has them also.
Okay, one question by Levi Spencer is about scripting. How do we expect on concepts such as visual scripting languages, like Unreal blueprints or Roblox scripts, so that the end user can make the metaverse without needing to understand the complex scripting program?
Well, you know, programmers are never going to let you do that, because you know, if regular people can build systems without having to program, then programmers are out of work.
But you also mentioned that one of the key is in these creative modes of online gaming is to have tools that everybody can use.
Absolutely, and so, you know, the thing is let's start out with this. Let's start out with Unity, because I think Unity is a good example. As a game engine, Unity provides some very nice tools to make it so that non-programmers can put together prototype games very quickly, 2D, 3D models. But as soon as you want to do something complex, like, you know, start building AI characters, and your AI characters are in a machine learning system, then you end up needing programmers probably for a while. But the answer is yes, we should make it so that it's really easy. What you really should be able to do is grab a 3D character that has all of the animations you want built in, and all you have to do is choose its clothes. And then built inside of that 3D avatar is a way to interact with sensors, so that you can use eye tracking sensors and hybrid EEG sensors that can be fed to that avatar and actually be interpreted and understood by the avatar. And so, but that means, you know, these are again high-level tools that we haven't yet built, and they will be built over time. And the real thing will be there'll always be some need for programmers, because there'll always be something that down at the bottom has to be tweaked that's not provided by the tools.
Okay. No other questions from the room, but there is one from Mike McCann. Metaverse development in the application layer of the internet stack inherently promotes a competitive environment. Is what you propose equivalent to the thin waist IP layer that can be used to promote and enforce a single metaverse?
Good question. I mean, I honestly think, all of my thinking is at the application layer for what goes on now. Because I think if you don't do it at that layer and you try to build it at different layers, then you're just going to cause great grief, right? You wouldn't be able to connect things to each other easily.
Okay, so reusing the existing infrastructure, just go on the application layer and...
Yeah, everybody wants to change the layers of the internet. Everybody would like to have the next internet. And the truth of the matter is, I think it's a very hard problem. It's a very expensive problem, because once you start changing a part of the internet, all of a sudden there's people who are not part of it, and there's people who would like to be part, and it's like a strange warring camp.
Yeah. Yes, we have one question there. Patrick, you still have the microphone.
Yeah, I was wondering if the university was going to include anything like ethics or bias prevention or ways to make it a safer universe or metaverse for women who don't get harassed within the first 10 seconds that they're online. So I was wondering if your university was going to cover that aspect as well.
Well, I think the Metaverse University absolutely has to have that. You know, right now on my slide, it doesn't say anything about having social scientists involved, or, you know, but you're making great points, and I absolutely think with machine learning systems that can rapidly understand what people are saying and communications they're providing, we ought to be at the stage where when somebody starts putting out harassing text, that the machine learning system grabs it immediately and says, we're going to put you on pause while we have a person review your comments. I mean, I think it's really simple to do this, but for some, you know, if I just look at Facebook, I just look at Instagram, I just look at WhatsApp, if I look at Twitter, I think we're going the opposite direction, which is they seem to make more money, against, you know, if there's harassing comments out there, at least from the political standpoint. And so they look at it as a money loser if they do something that goes and takes away the pain from these social platforms. I think the only way to get there is with legislation, which basically means a university has to create the tools that can easily be popped in, that can check what's being said and come up and say, and flag it and say, and hand off to the operators of the future metaverse social universes comments saying, hey, this person needs to be pulled out and talked to. And I think that has to be automatic. That can't be 10,000 monkeys in a room reading posts, okay?
Okay. Clear. Actually, this was one of the first items that Nicholas mentioned today, the digital rights of a person. So we start the day and we end the day with the same clear issue that we have. And maybe it comes also from the fact that our rules and legislation in real life they are not yet adapted in the digital life, or were simply not used in the digital life, because someone that in the real life would never say something wrong to another person, he or she is doing that very easily on the web.
Yeah, and the biggest issue I think in the United States with respect to legislation is there are very few of our congressmen and women and senators who actually even use email, okay? Yeah. So their staff might use email, but they don't. They probably have their staff print out emails. So there's the problem with that. With age, that will go away.
Yeah, the biology will do its job.
Biology will do its job. I am 68, and most of the senators and congressmen that are in control are up in the late 70s, early 80s, and so they're not going to be. This is not going to happen with them.
Yeah. Same in Europe. Don't be afraid that you are alone.
Yeah.
Okay.
Well, so the truth of the matter is maybe there should be a special interest group called Open Legislation. Which is, if we had our druthers, we would like our social networks to be policed for hate speech, and provide an architecture for it, and to provide a way of dealing with it, which is, a lot of it is pull that person aside out of the online system and put them in a room until a live person can talk to them. And I think so. Open legislation group, and it should be global. I'm very big into global. I'm working on another new school which is called Global Artists, and we're looking at a part of it in Los Angeles and a part of it in Seoul, Korea, and a part of it in Dubai, and maybe a part of it in Jakarta. But we'll put it in other places as well. Of course, Europe.
Great.
Once I have my EU citizenship, which should happen by December.
Yeah. We have a request here to install one in Paris.
Yeah, of course. I know from knowing Don Brussman that Paris is a great place to visit. I have been there myself many times.
Good. Any other questions or comments? People from online? No, I think we are done. Thank you very much for the inspirational talk. That was great to have you with us.
Oh, thank you for the invite.
Yeah, and we keep in touch. We look forward to send some of our students to your university to have a master degree there, or to complete their study. That will be with pleasure.
At the Metaverse University.
Yeah.
See you soon.
Yeah. Okay. Good.
Please have a great day.
You. Yeah. Thank you all for the participation to the sessions of today. So tomorrow morning we start with Marc Petit, which is he's from Epic Games. So we will ask him a lot of things about how he wants to play in this interoperable metaverse. So he will just maybe say, we don't believe that interoperability is something for Metaverse, but we will see tomorrow. So that is an invitation for you to come tomorrow. Tomorrow, everything happens here. We will have only one track. So we'll have the keynote in the morning, then the regular session and the interoperability workshop and panel in the afternoon. Okay, for the ones who are not who are living here in Evry, you have the possibility to have the dinner in the restaurant where you had the lunch. The difference is that you just show your badge and you take a plate and you serve yourself. Okay? Thank you very much and see you tomorrow at 9. Online people, see you tomorrow as well at 9 CET. You have to translate it in your own time zone. But it was a pleasure to have you also connected. See you. Bye bye.
Thank you. Bye.